Welcome to the sixth video in the Introduction to Simio series, and in this video we're going to cover two basic topics. First of all, we're going to talk about buffers and where entities can reside in the system as it runs, and then secondly we're going to talk about reference properties and how we can use reference properties in conjunction with our experiment to analyze systems, and then we'll have our first workshop. And so we're going to start with the model that we've done for the last couple of videos, which is our simple flow system, simple assembly or flow line system. So let me grab that model where we left it off last time. So you can see that, and let me just go ahead and run it, and we can discuss some of the things while we run. And so what we want to start with to talk about this topic of reference properties, we want to start with the notion of buffering. And so as we said, when entities arrive to a server and that server is busy, the entities wait, so you're waiting in queue here. And so the question is, when we look at our model, the queues are represented by these green lines in the animation, and these green lines are actually Simio queues. In Simio, a queue is there's a logical queue where the entity just resides from an animation perspective, and the actual entity resides within a station. We're going to get to stations later on. So for now, let's just focus on this notion of entities in queues. And so I'm going to make a couple of quick changes here. The first thing I'm going to do is I'm going to delete the input buffer contents for the sink, because in our model entities just leave, so there's no queuing at the sink. And secondly, I'm going to select server 1, and there are three locations. You can see that we have three. I can zoom in here. We have three of the locations where entities can reside: the input buffer, the contents where the processing actually occurs, and the output buffer. And of course we have the same thing for server 2. And so in our model, the output buffers aren't used because entities that depart server 1 go immediately to server 2. If server 2 is busy, then the entity just waits in the input buffer of server 1. So what I'm going to do is I'm going to go into server 1 and go to the buffer logic property, and I'm just going to explicitly set the capacity for the output buffers to be 0. And you will see why I'm doing that here. We'll discuss why I'm doing that in just a little bit. And secondly, I'm going to then do the same thing in server 2 and set that capacity to 0 also. And so now when we look, we see entities can either be in the output buffer to the from the source, the input buffer to server 1, the processing station of server 1, the input buffer of server 2, or the processing station of server 2. And so we've set these equal to 0, so they don't really play any role, so I can go ahead and delete the animation component of those also. And so from this perspective, when I run my model, we haven't really made any changes, because while we set the buffer capacity to 0 for both of these, those buffers were never used anyway. And so the model now is going to run in exactly the same way as it did before. So looking at our three buffers, the output buffer for the source, the input buffers for server 1 and 2, if we look at the source object and the buffer logic property, we see that by default these buffers are set to infinity. And of course, in a real system, we can't have an infinite size buffer. And so suppose what we would like to do is figure out what a buffer strategy should be. In other words, what should the buffer size be for the source and the server and our two servers. And so to illustrate that, what I'm going to do is I'm going to go in the source and I'm going to set that buffer capacity to 0, meaning entities can't buffer on the output. And then I'm going to add capacity 1 to both of the server 1 and server 2 capacities. So now what I've done is I've taken the infinite capacity buffer as source, changed it to 1, the infinite capacity input buffer for servers 1 and 2, and put those to 1 also. So now the question is, well, what happens when an entity arrives to server 1 and server 1 is busy? Well, if there's already one entity in the buffer, it can't transfer in because we've capacitated that buffer. And since the source has a capacity of 0, that entity would then balk. By the logic of the source would say, okay, I'm just going to throw that entity away. And so we would in essence lose that potential customer or part or whatever we happen to be modeling. So if we run this and see what's happening, we can see that this buffer, let me increase the speed a little bit, whereas before was moderate in sometimes. It never gets larger than 1 because we're limiting that capacity. Also, occasionally when we run, we're going to see the server turn yellow. And in that case, well, hopefully it'll happen while I'm talking, but in that case, if we have a server 2 is busy and there's already an entity in the queue, and the entity in server 1 is finished, it's trying to transfer into server 2, but it has nowhere to go because the buffer's full. There you go, yellow. Because the buffer's full, the server's full, and so the server 1 is in essence blocked. So by setting the buffer capacities, we're implementing this notion of blocking where there's nowhere for an entity to go, so it just sits at server 1. If there's no room in the output queue of source 1, that entity blocks. And so from a throughput perspective, we would lose that throughput. So that having capacitated buffers would reduce our throughput. So let's go to our experiment and have a look. And so I'm going to go to my experiment. And we can see previously we had a throughput of 24.37 when we ran 10 replications. And so we'll just run 10 replications under a capacitated buffer. And we can see that our throughput has dropped pretty substantially down to 17.3. And so the loss in throughput is due to that blocking caused by the capacitated buffers. So suppose I wanted to look and see, well, how much would the throughput increase if I added some buffer capacity? So one option would be to go to server 2 or server 1 and say, well, let's increase that to 2, and go to server 2 and say, well, let's increase that one to 2 also. So now we have capacity 1 here, 2 here, 2 here, and let's see from an experiment standpoint what that does. So we were at 24 initially, we're at 17 now, a little over 17, and now when we run, we see that we've actually recovered some of that throughput exactly as we would have expected. And so we could continue to experiment in this way by manually going back and changing the buffer capacities and seeing the output on throughput, seeing the effect on throughput. However, a more effective way to do this, or a way that simplifies the modeling, is to create what are called reference properties representing the server. So to make my presentation a little simpler, we're just going to assume that source 1 always has capacity 0. So we're not interested in that. What we're interested in is the server capacity, the buffer capacities for server 1 and server 2. So what I'm going to do is I'm going to go to server 1, I'm going to go over to the input buffer capacity property, and then I'm going to right click and choose the bottom set reference property, and there's an option at the bottom to create new reference property. So I'm going to call this buff for a buffer 1, and notice that what CMEO does is it has buff 1, which is what I named it, and this little green arrow. So this little green arrow means that we have what's called a reference property. So before I show what that is, let's go and do the same thing for server 2. I'm going to go to my capacity, set reference property, and notice now we have buff 1, the one that we previously created. I'm going to create a new one and call that buff 2. Buff 2, and so now we have 2 reference properties, one buff 1 and one buff 2. So what are these reference properties? Well, I'm going to go to the model. I'm going to still be in the model. I'm going to go to definitions, and I'm going to look here under properties, and you can see the standard properties defined by the object, but here are the 2 that I just defined. So we have buff 1 and buff 2, and you can see that these are both integer and they have a default value of 2. So at this point, if I run my model, I'm going to get the exact same behavior that we had when I hand-coded 2. And so again, we can change those values. We could go back into the definitions and change the default values. But an easier way to do that, since it's defined as a reference property, is to look at the model properties. So here's the fixed model properties. And now we have a new section called General, which has our 2 reference properties. So I could go here and say, well, let's make this one 4, and let's leave this one back at 1. And then if I run my model, we would see that we now have capacity 4 here, and we still have capacity 1 here. So by defining the reference property, it gives me a simple way for me to edit the properties at the model property level. More importantly, if I go to my experiment, we now see our 2 reference properties set up as what are called experiment controls. So under the experiment controls, I can then set these just for the experiment. So if I reset and run, you will see that we get the same 19 here. If I go set this to 1 and 1, for example, now I'm going to get the values, the 17 value that we got when we did it manually. So what this provides us a mechanism to do is by setting those controls in the experiment rather than in the interactive mode. So if we jump back to our presentation, you can see that this is the process we did, is we just defined the reference properties for server 1 and server 2, and that defined these two properties in the definitions properties portion under the model. And of course, in the video I named them buff1 and buff2, but this S1 buffer is just simply the name. And so if we go back to our experiment, now what we would like to do is be able to do an experiment with different buffer capacities. So I can go below and let's just say, let's name a scenario S0, and we'll call that our default. So we'll just set these to infinity. And then that represents our baseline, that if we have an infinite number of buffers, and then we'll define S1 and set this equal to 1, 1, which is essentially what we just did. S2, set this equal to 2, 2. S3, 3, 3. Don't worry, I'm not going to go too far. S4, 4, 4. Oops, 4. Let's just go up to 5. S5, 5, 5. And so now our experiment includes, let's just deactivate this one because we don't really care about that, so I'll just uncheck it. Now we have 6 scenarios that we'd like to evaluate. The baseline with infinite buffer capacity, and then we systematically increase the buffer capacity by 1, having each buffer be the same. And so you can see that our throughput, as we would expect, started at 24, which was our infinite capacity case, and then dropped down to the lowest value we saw with capacity 1 buffers, and then systematically increases up to 22. And so let's just look at one more scenario. Let's just increase it to 10 here, S10, and let's just make capacity 10 buffers between each one. And let's just run that final scenario. And so now you can see that of our 24 that we had with infinite capacity buffers, we're about up to 23.8. So we've recouped by having capacity 10 buffers most of all of what we lost. And so what having these reference properties allows me to do is set up different scenarios to do a side-by-side comparison. And if we look at these in our response results, we now see, let me turn off the histogram here, we now see side-by-side s'more plots for our scenarios, for the individual scenarios. So let me go back and turn off our baseline, because as I said, we can't have infinite buffers. And so this gives me a way to compare directly the individual scenarios that we saw within the design. So it's a very nice way to look at the model results. Of course, if I look at the pivot grid, I can also see all of the results in a numerical fashion, or in the tabular fashion. You can see scenario across the top, and there's our S1, S10, S2, and so on. So we have this nice tabular view that lets me customize and sort and group and so on. So to summarize, by defining reference properties, it created automatically controls for my experiment, and that lets me create individual scenarios to do this direct comparison of different scenarios. So back to our PowerPoint here, and you can see this essentially is the same thing that I just mentioned. One quick note here that I forgot when I was doing the development, go back to my model here just a second, is when you look at these values, when you look at the replication values, you're going to note that these replication numbers are not in order. So we have replication 2, replication 1, 5, 3, and so on. And that's because Simio uses all of the available processor cores. So if you have a quad core, an 8 core, a 2 core, it's going to run replications simultaneously. And so those numbers, the completion won't always be in sequential